Hello and welcome to another episode of Elktech. Today we are going to go into our fourth video in our tutorial series about the inside of a computer and how it works. So we're talking about all of our internal components and things like that and how things work. We've talked about the case, the motherboard, and the CPU so far. So if you haven't already watched those videos, I recommend going to my website, which is in the comments below, and check those videos out first. So today we're going to talk a little bit about cooling systems. It's really important to talk about cooling because the inside of your computer gets really hot. The more cores you have in your processor, the hotter that's going to get. Your video card is going to get hotter based on what type it is and how much you're using it, so on and so forth. The components are just going to get very hot in there, and we need to keep it cool. So one of the first things that we're going to do in order to keep things cool inside of our computer is the use of a heat sink. So we put this on top of the processor along with what's called thermal paste, and this thermal paste basically allows for a really nice transfer of heat from the processor to the heat sink. Make sure you're using thermal paste. It's really cheap. You can find it on Amazon, eBay. You can probably find it down at your local hardware store. So make sure you get some thermal paste, and then you put the heatsink directly on the processor with a little bit of thermal paste in between. And as you can see in the diagram on the right, basically what happens then is that the inside or the bottom of the heatsink is going to absorb a lot of the heat from the processor so that we can then try to get rid of it. What we do to get rid of it is we use a fan. So on the left hand side you can see a fan on top of that particular heatsink there, and what it does is the heatsink absorbs the heat and then the fan blows that heat off. There is no actual way to make cold air. All you do is absorb heat and get rid of it, so that's what we're going to do here. In the picture on the right, what you can see is you have your fans on the bottom and on the right hand side, which are designed to actually suck air into the computer. And then you can see with the red arrows on the back toward the left side and on the top, those fans are then pushing air out of the computer to make a nice air flow through. So you're pulling in the outside air to come in, absorb the heat off of the heatsink, and then push it back outside of the computer. Cooling is key. Make sure that you have a lot of cooling, especially if you're going to do some overclocking, or if you're going to really put a lot of components in there like dual video cards, things like that. You're going to need more cooling. Alright, so as you can see in this diagram, there are actually two fans right in here that help suck more air through the computer. This is an option that you can do based on the case that you purchase. You can add fans to the top, usually on this side panel here too. You can also add fans that come out this way. I don't see too many computers that are actually sucking air in from the bottom anymore. Most of them, you just buy the really large fans from the front that are sucking in, but you can add those ones there at the bottom. The last thing we're going to talk about is liquid cooling. Now this is a lot more expensive, but this if this doesn't keep your computer cool, nothing will. So basically what happens is you put this block right here. It's a large metal block here that is designed to absorb heat from the motherboard. You then have the liquid that flows through this channel right here and around, which basically keeps this metal super cool. It absorbs all of the heat, and then as the liquid absorbs that heat, it's going to flow through the radiator, and it is then going to get cooled off by the fan. The fan's going to blow air. Again, we're going back to, we still need these fans with liquid cooling because it's going to suck air in. Alright, and then it's going to blow it through to the radiator so that the radiator can take that cool air that was blown in, absorb the heat from the liquid, and blow that out of your computer. The pump right here is then connected to the other side of the radiator, which is actually pumping the liquid through. Goes into our liquid level flow indicator so that you can always see that you have liquid. As your computer gets too hot, it could flash some of that off, and you could eventually lose liquid. It shouldn't happen very often unless your computer is running at a super high temperature, which it really shouldn't. And then it comes back in here to the water block on the motherboard. So again, this can also be dangerous. If it runs a leak, you're looking at electrical damage, things like that. But it is a great way to go if you can afford it and actually want to go that route. I haven't seen too many computers where you actually need to go the route of liquid cooling. Thanks to mintywhite.com for the diagram. Great diagram. Thank you guys for tuning in. Make sure that you subscribe to my YouTube so you can see all the latest videos as they come out. Also check out my website. As I said before, it's down in the comments section. There you can find the rest of the videos in this series, as well as many other tips, tricks, and other videos on how-tos for various things in technology. Thanks again for watching.